Hi, class. My name is Dr. Danju, and today my task is to talk to you all about ANOVA, analysis of variance. Now, this might be a little confusing to many of you, but we actually did a test for variance. This is not that, all right? We're actually using means, and what we're doing with these means is we're testing to see if there's variations in these means. The status quo, the null hypothesis, is that these means are equal. That is what is standard. That is what is the historical data, that all of these means are equal. The alternative hypothesis is at least one of these means, the variation is different. At least one, it could be one or more of these means are statistically, there's evidence to prove that there is a difference. So that is what I want to talk to you all about today. Can we look at this ANOVA, this analysis of variance, and tell whether these means are equal or are they different? If it's rejected, at least one of your mean is statistically different from the rest of them. All right, so we're going to jump into this. What I'm going to do is share my screen with you all. All right, don't forget you can find this stuff. Please log into Cengage. All right, I'm going to click on this, and you guys can also download the chapters 13. All right, so right here, download chapters 13. Also go into Cengage, please. While we're doing that, I'm going to hide this. All right, so log into Cengage. Make sure that you understand this concept. For this final exam, we're going to be covering chapters 12, 13, and 14 and 15. Guys, for these chapters, this will show up on your exam. So make sure that your Excel templates are working. Make sure it do what it do for you. Make sure that it makes sense to you. All right. So on this one, all right, we're going to go topic 7, task, and we're going to go into chapters 13. Outstanding. Let that roll. We're going to start the assignment now. All right. So what I'm going to do is I'm going to do this side by side. And if you guys can, please, let's start off with 13.01. 13.01. So I'm going to minimize that like that. I'm also going to give me a little room over here as well so I can see it all. And we're going to 13.01. All right, this is going to be the very last one. Looks like it. All right, here we go. 13.01 is this information right here. So just like before with our templates, you put in the information and automatically you will have your results. But you guys are going to have to interpret what are these results actually saying. So for example, take this information, plug it in. Remember, junk in equals junk out. All right, I'm not going to do the sample mean because I'm going to be able to calculate that, or they already provided to me right here. All right, so what I'm going to do is I'm going to go, actually, let me copy this first, highlight it, copy it, and I'm hoping that I could just paste it right in here. All right, it's kind of twisted, 162, 142. All right, so what they did was, all right, so 142, 156, 122, it kind of shifted over. So if you can just highlight it and just drag it over, just like that. All right, just eyeball it, make sure your numbers are correct so there's no issues. All right, one of the first things we want to show you is that you can use Excel to calculate this test for ANOVA in a really fast way. So I'm going to maximize this. We're going to be using the analysis single factor test. All right, so how do we do this? If you guys click on data, data analysis, and look for ANOVA single factor. It should be right there on the very top. All right, ANOVA single factor, click on OK. All right, what are your input values? Please include the labels so that way you know which ones are your columns, which ones, for example, A, which one is B, which one is C. All right, so what I'm going to do is click on this input range box right here and highlight from A all the way down to my last number under C. All right, these are in a column. I'm going to select labels in the first row. All right, and I'm going to put my output, I'm going to move this over. I'm going to put my output right at this orange box right here at H1. All right, put that right there and click on OK. And click on OK. Automatically, Excel provides me the output right here. Wasn't that quick? Wasn't that easy? Now, you can manually calculate this, or you could use Excel and get this automatically. I would highly recommend that you use Excel to get it automatically. But what does this say? All right, look right here. How many A's did you have? How many B's did you have? How many C's did you have? These are your sample sizes. What is the sum of all of A? Here it is. What is the average of all of A, B, and C? What is the variance of all of A, B, and C? All of your numbers are right here. Excel provides you this information automatically. All right. Now, how does your ANOVA test actually work? It works like this right here. All right. The main things that you're looking for is your F stat value. This is your test statistic. It is 5.49754. All right. This is your test statistic. This is the value that determines whether to accept or reject the null hypothesis. How do you know what to accept or reject? For these ANOVA tests, these are a right-tailed test, all right? Here is your critical value, 3.68. So if you can see in your mind's eye that beautiful bell-shaped curve with the right tail being the rejection zone, the critical border, the boundary that separates the rejection from the acceptance is your critical value. If that is at 3.68, isn't 5 somewhere out here in the rejection zone? So basically, one of these variances is not equal, if that makes sense. Anyways, I'm just going to fill out the rest of these. I'm going to minimize this just a little bit so I can see it all. All right. What is my sample mean? All right. It all depends on which one I'm talking about. All right. And you can calculate that, or you can input it from the problem itself and plug in those numbers. But what is your sample mean for A? All right. So sample mean is the same as your average. So you can put equals to this guy right here. Hopefully this is making sense. This guy equals to, what is your sample mean for B? What does your sample mean equals to for C? All right. What is your variance for A? What is your variance for B? And what is your variance for C? Equals to, and just click it. Try to avoid typing it in. When you click it, if these change, it will automatically update here. If you type it in, you manually have to change it. So click it and get it right. All right. So what is the sum of squares between treatments? All right. Sum of squares, SS, sum of squares between. So that is your number right here. And this is within. Let me see sum of squares. I can't see it all. The mean squared between treatments. All right. So between the mean, sum of squares, the mean squares, all right, between and within, all right? So you can plug in these numbers. It's equal to this number right here, sum of squares between treatments, bam. The mean squared between treatments equals to the mean squared, bam. The sum of squares due to error, all right? The due to error is the within the part, all right? So this one is sum of squares that's equals to within, or the error is that number right there. And the mean squared for the error is that number right there. All right. And you can fill all of these out. All right. You can put equals to that. All right. And I think you should be able to drag it over. Okay, let me press enter. You should be able to drag it over and it should automatically fill that in for you. Good, good. All right. You should be able to click this one right here and drag it down. Good, good. Ooh, hold on, hold on. Be careful with this total. All right, this total, there's an empty spot there. So it's going to give you 0. So you're going to have to change that one. Equals to this number right here. This total right here is equals to the degrees of freedom right here. All right, and you can just drag this down 1. Let's drag it down like that. All right, you can do the same for this, drag it down. Let's make sure your numbers match. All right, and then this, what is your test statistic? Equals to your F value. What is your P value? Equals to your P value. All right, and as we get into chapters 14 and 15, the P value is also going to be called your significant value. So we're going to see what that is, or your significance of F. All right, and that is your overall P value. And then what is the conclusion? Reject. All right. If your P value is less than your alpha value, all right, 0.05, reject. All right. If your P value, or if your F stat value is greater than your F critical value, reject. All right. I know that was a lot. I'm going to drag this over like this. And let's enter some information right here. 1488. Cool, cool. I'm just going to do this one, 17. Cool, cool. And what is my test statistic? 5.50. All right. And I'm just going to check my work. Bam, bam, and bam. So take your time on these, fill in all of this information, use the data analysis toolkit to get this stuff automatically. But once you have this stuff, what is it actually saying? All right, make sure that you know that this F value is your test statistic. And then we should be good to go. All right, with that said, you guys should be able to fill out the rest of these. Please, let's move on to 12.05. Please be aware that some of these will appear on your exam. All right, this is one of them that will appear on your exam. So make sure you understand this concept and you have a way to replicate good, successful practices. So when you show up to the exam, you are well prepared. Make sure that these Excel templates do what it do for you. Up here is the formulas. Down here is where you will enter the information. All right, so we're going to go to 13.05. Let me make sure. Oh, look at that. It's the very last one. All right, and we get to plug in these numbers. Well, watch how this works. In a completely randomized design, 12 experimental units were used for the first treatment, 15 for the second, and 20 for the third. So here are your treatments. Yo, man, what was my first one? 12, cool. What was my second one? 15, cool, cool. And what was my third one? 20, cool. Automatically, you're gonna see the number of treatments is 3. If there was extra ones, you could plug it in. This would automatically update for you, all right? And then you can find your N total. Just based on these numbers, you can find your sample size total. It is right here, all right? If you double click on it, it will show you it is the sum of all of these, and that's how we came up with the sample size total, which makes sense, hopefully. All right, now, here, you see how they provide you 1,200, plug it in. Everything in yellow will automatically update as you start plugging these numbers in. This one right here is 1,600. All right, and you should have everything else that you need. So all you would then need to do is plug it in just to make sure you got this right. I'm just going to do 2 of these. Check my work. All right. So make sure you have a system that works. So when you show up to that exam, you plug in the number of treatments, you plug in the information that they provide you, all right, the sum of squares for your treatment, the sum of squares, the total sum of squares, you plug those values in and everything else should be automatically calculated. If you want to see the calculations for each one of these, they're up there, but you can also double click and you can see how it's actually making the calculations. All right, so that is excellent. Now, the next question is MC 13.006. Please go to that one, please. All right, where are you hiding? And okay, number 2. All right, so here's a multiple choice. This will show up on your exam. All right, for some reason I can't really see what those letters are. I'm gonna move between A and B. I'm gonna take my mouse, put it right between A and B and drag it over so I can see what this is saying. Perfect. All right, if F ratio in a completely randomized ANOVA is the ratio of what? All that is to say is what is the formula for your test statistic, your F stat value? All right. I know they worded weird, but if you get the concept, it makes sense. What is the test statistic formula? All right. It is your MSTR, all right, your mean sum of squares for your treatment divided by your mean sum of squares for your error. All right. And you can check your work, make sure you are right. All right, this will be on your exam. So make sure you got this one right. All right, that one, if you can't click on these dial circles, all right, and for some reason, mine is all messed up. They're all down here. So what I'm gonna do is just highlight this, go all the way down to 5. All right, and I'm just gonna make between 2 and 3 bigger. I'm gonna drag it down to like right there. So all these fall in place. All right, and then what I'm gonna do for this one is highlight it, make it like blue in my case, or red, all right? So I know that's the answer. So when I show up to this exam, I'm not guessing. I know what is the F-stat formula. It is this, sorry, wrong one. It's the last one. Make sure you selected the right one, all right? So I'm gonna do that. Give me a second. Yes, make sure you get the right one in there. Oh, this is just, give me that. This one is red. All right. Yes, make sure you get the right one in there. Don't be like, you know, selected the wrong answer. MSTR divided by MSE. All right, and you should be good to go. All right, let me make this just a tad bit bigger. All right, so I can see this correctly. All right, let's move on to 13.09, please. 13.09. I'm gonna make that one smaller so I could see them all. All right, 13.09. Find it, bam. All right, then enter all of this information right here. You should be able to highlight it, copy it. All right, paste that. All right, it keeps shifting it over, that's cool. All right, just grab this one right here and drag it over. All right, make sure your numbers are right. Cool. All right, so that is the correct information right there. What we're gonna do is an ANOVA, once again, single factor test, get this knocked out really fast and answer our questions. All right, so all you need to do is data analysis, select that first one, click OK. All right, remove all of this, delete it. All right, and we're gonna select our new data set. All right, so come up in here, select it all, cool. All right, this is in a column, cool. Labels, cool. And we're gonna put this right at H1. All right, right there at that orange box. Click on OK, man, give me my stuff, okay. And you have all the answers that you need. All right, so you can put them over here or you can use this. All right, just make sure you know what is what. All right, what is your F value? Equals to, bam. What is your P value? Equals to P value, bam. What is your conclusion? All right, do you accept or reject? Watch this really fast. All right, if my F value is 1.10 and my critical value is 3, isn't this less than 3? So this is in my do not reject zone. All right, so in my example, it's do not reject. All right, and now you can plug in your stuff, all right, and get all of these answers. All right, I've showed you before how to get those. All right, I'm just gonna plug in this one just to make sure I am right. Check your work. Scroll down, bam. All right, so take your time on these. Make sure if you select the label, make sure that you have labels checked in that analysis toolkit for ANOVA single factor test. If not, when you do your analysis, let me go back over here. All right, you're not going to see 5, a count of 5. It's going to look all funky. All right, so make sure, and you should see the groups right here. If you see numbers right here, you did something wrong. It should say 50 degrees Celsius, just like it says up here, 50 degrees Celsius. These are the labels of your columns. All right, let's go to 13.12, please. All right, so once you get these concepts, the rest of these should follow the same pattern. All right, so we got Italian, seafood, steakhouse. I'm hungry, y'all. Read these examples for the business, how it relates to actual practical business examples. All right, so plug in your information. All right, so you see how these have dollar signs in there? This might mess you up a little bit. So what I would suggest is you don't need the dollar signs in there, type it in. All right, don't forget, junk in equals junk out. Take your time typing this stuff in. All right, I know I'm rushing, so if I get it wrong, don't use me as an example. All right, 17 and 19. All right, I got my stuff done. Hopefully you got it done right. Hopefully I got it done right. All right, I'm gonna maximize this. Let me make that just a tad bit smaller. All right, I'm gonna do an ANOVA single factor again. All right, by now you guys should know how to do this. All right, I'm gonna walk you guys through this a couple more times. All right, get it all, get it all, get it all. Column, I did select my label. All right, and I'm gonna put my output right here at H1. All right, clicking OK. Give me my stuff, man. Got it? All right. Now, you should know what your p-value is. You should know what your conclusion is. All right. What is my p-value? Equals to p-value. All right. What is my conclusion? All right. 7, here's my test statistic, 7. All right, here's my critical value, 3. This is in the rejection zone. This is to the right of it. It's a right tail test. So I would say reject. Let's go, let's go, let's go, let's go. All right, so what I'm gonna do for this one here, I'm gonna scroll down on this. All right, so it doesn't need, okay, so what is my F out? All right, so I'm just gonna scroll over. All right. I'm just gonna plug in about 2 of these, 226.0, how many decimal places? Whole number, you see that? 2 whole number. So I'm gonna put 226. I'm gonna put for degrees of freedom, 23. And for this guy right here, 2 decimal places, 15.68. Check your work. Scroll down. Yes, yes, yes. Come on, come on, come on. All right. Take your time with this. Get your analysis toolkit, ANOVA, single factor. Get your labels. Make sure you got everything selected right, and you should be able to get these answers and the conclusion. All right, moving right along. 13.15. 13.15. All right. 1715. Same concept, y'all. Plug in your information. All right, let me see. Highlight it all, copy it, and paste it. All right, it shifts it over. All right, maximize it. Just grab this junk right here, shift it over. All right, you got your stuff right here. Guys, on this, yes, let me do this one so you can actually see how this works with Fisher 3-sample LSD. All right, so once you plug in this information up here, everything else should be automatically populated down here. All right, so give me a second. Analysis, ANOVA, single factor. All right, I'm gonna delete that. I'm gonna do this. All right, from A1 to C5, labels, good, good, good. And I'm gonna put this right at F1. Click on OK. All right, so I got my information right there. All right, so you guys can plug in. What is the sum of squares for your treatment? Sum of squares, the first one is your treatment. Sum of squares for your error equals to this guy. The mean squared for your treatment is equals to, I'm gonna have to make this smaller. I apologize for those of you who are online and can't see this. All right, I'm just gonna make this a tad bit smaller. All right, this is that, enter, equals to that, enter. What is my F stat value? Equals to that. What is my P value? All right, and what is my conclusion? So 53, my critical value is 4. So 53 is way out yonder, so it will be rejected. It's a right tail test, don't forget. In my example, it will be rejected. All right, so now that I got all that stuff, you'll see all this stuff populated for you. Now you can answer these questions. All right, so I'm gonna scroll up and over. All right, I'm just gonna plug in a couple of these. So like this one here, guys, just make sure if you go to home, the numbers, move it over, move it 2 decimal places. Let Excel do the work for you. All right, these are all 2 decimal places. All right, I'm gonna even do this one, 2 decimal places as well. All right, so these 2, I'm just gonna move those over like that. All right, so for this guy, now I'm just gonna plug in the first one. All right, plug in your numbers. Each of us have different numbers. So plug in your numbers. And what is my test statistic? 53.45, check your work. Outstanding. All right, now where do you calculate your Fisher's LSD? Guys, let me maximize this so you can see it all. All right, if you look down here and scroll over, do you see Fisher's LSD? Is 2.72 right here, 2.72. So I'm just gonna drag that back over and I'm gonna say 2.72. Let me check my work just to make sure I got the calculations correct. And I do not. All right, so let's see what is happening with my Fisher's LSD. So I'm not sure what is happening with my calculations for my LSD, all right? But make sure that you reach out to your professor and see how to calculate that. This will be on your exam, so we gotta make sure that we get this correct, All right, so calculate your Fisher's LSD. All right, let's move on to 13.17. All right, it should be this guy right here. Cool. All right, same concept, plug in your information. And I'm hoping that my Fisher's LSD is correct on this one as well. All right, so plug in your information, do an analysis single factor, plug in all your information, and you should be able to get all of your answers. All right. I am not going to do this one. Hopefully you guys got an example and you should be good to go on this one. All right, it's the same as 13.15. All right, so I'm going to go on to 13.23. All right, yes, this is the one I want to do. All right, on this one, all right, so I'm just going to select something in here. All right, let it calculate so I don't select it again. All right, so make sure you work this one out, enter your information, do an analysis toolkit, all right, and keep that pushing. All right, so let's go to 13.23. All right, 28. All right, here we go. So they're going to provide you some information, the 800, the 500, the 1700. You plug those numbers in. You should be able to calculate your degrees of freedom, your mean, and all of the rest of the stuff. All right, so watch how this works. Just plug in what you got. All right, 800, 500, 1700, cool. All right, what is your degrees of freedom? Let's see if they provide us that information. All right, an experiment has been conducted for 4 treatments with 8 blocks. 4 treatments of 8 blocks. So how do you find your degrees of freedom? Treatment is the same as K, all right? So K is, we got how many? 4 treatments, so 4 minus 1, all right? So in this one, you put equals to 4 minus 1. All right, that's really dark. All right, maybe I need to give this a lighter color so you guys can actually see this. Bam. And I'm gonna do this one as well. Bam. All right. So how did you get this? 4 minus 1. In my example, they say 4 treatments. That's 4. All right. And then how many blocks? Up. Delete, delete. That's 4 minus 1, enter. All right, this one right here is equals to 8 blocks. So that would be B minus 1, 8 minus 1. All right, so that is how you calculate your degrees of freedom. Columns is how many treatments, blocks is how many blocks. All right. And you should be good to go. Let's test this out. So 400. All right, and I'm also gonna put in 28 right here. All right, and I'm just gonna do one more just to make sure. And they want 2 decimal places, but p-value 4 decimal places. If the answer is 0, put 0. All right, so I'm just gonna plug in one of these crazy numbers right here, 26.66. Check my work. Actually, I should have put 0.67. All right, it still took it. All right. All right. So why isn't 28 correct? All right. Let's double click on this. All right, enter, double click on this one. Make sure you have all of your totals. Make sure you have all of your totals. So I'm going to drag it up. All right. So it should be this, this, and this to get you 31. Make sure you have this set up correctly. Check your work. And you should be correct. Do you see right here, n total minus 1, all right? Or n minus 1, all right? basically, to find your degrees of freedom, the total degrees of freedom, it's all of these combined to give you your total. All right. So now that we have this, we can fill out the rest of these and get these answers, and you should be good to go. All right, let's wrap this up with the last two. Can we go to 13.28, please? I think that was up here. All right, so this is one of those funky tests, all right? Please follow along. Hopefully it will make sense, all right? What we want you to do is plug in these numbers in here. So take your time with this. All right, 116, perfect. Now that you have this, we're gonna show you another test, an ANOVA two-factor test. And how do you do it when you have two different levels or layers? All right, how do you calculate it using ANOVA two-factor test? So what I'm gonna do is, let me zoom out, press enter. So you're doing ANOVA two-factor with replication. So the way this works is if you go to data, data analysis, two-factor with replication. With replication is like if you go to a party, all right? And they're saying that we're gonna pick a person out of the hat, all right? If you put all the names in a hat, I'm gonna pick one person out of that hat, all right? And that person is gonna win, let's say, a prize. Now, with replication is you take that person's name and then put it back into the hat, all right? So that way that person has a second chance of winning. Listen, they need to stay out. If you're making sure that that person stays out, that is without replication. With replication is if that person goes back into the pile, all right? So we're gonna be using an ANOVA two-factor with replication, clicking OK. All right, your input ranges, all right, you can select from this empty box right here all the way down. All right, how many rows? You got two levels, all right? You should put 2, all right, 0.05, and we're gonna put the output right here. All right, I think I got it all. And we're gonna click on OK. Okay. All right, so here is our information right here. We got levels 1, 2, and 3. All right, and we got 2 basic levels, level 1 and level 2. All right, and we should have all of our information right here. And here down below is where we'll find our sum of squares, our mean squares, and our test statistic and our critical values. All right, so that is a lot said. Each of us is going to have different numbers. So just enter your information down here. And what is your conclusion? If this is a right tail test as well. So if your F value is greater than your critical value, reject. All right. So what I'm going to do is I'm just going to use this right here to answer some of these questions. I'm going to do this side by side. All right, scroll it over. All right, so sum of squares for factor 1, and they want 2 decimal places if necessary, and p-value for 4 decimal places. So your p-value, they want 4 decimal places. So take your time with these. I am hoping that their decimal places are correct. All right, I'm gonna put 3, 3. I'm just gonna randomly select a bunch of these. All right, 736.33, actually 2 decimal places. All right, and my F value is 9.94. And I'm just gonna do one of these p-values just to make sure, 0.1849. Let's check our work. All right, at least for the numbers I've plugged in, they work. If for some reason you're having issues with your decimal places, please let your professor know, all right, and they will check it out more closely. But for this first one right here, you see where it says 2.24, and the critical value is 5.98. Do you see how this number is to the left of 5.8? So this one should be not significant. All right, just check your work just to make sure. And scroll over, and that is correct. All right, or do not reject. If it's not significant, it's do not reject. If it's significant, it is rejected. All right. Uno más, one more, one more, one more. All right, so this one is 13.39. Please go to 13.39. All right, plug in this information, please. Take your time on these. Can I copy this? Looks good so far. Copy, paste. Cool, cool. So I don't have to do anything else. All right, I'm gonna maximize this. We're gonna do an ANOVA single factor just like we did before, and we get to see our Fisher's LSD. All right, so I'm just gonna do data analysis, single factor. All right, I'm gonna delete that, and I'm gonna highlight from nurse all the way down to number 7, columns, that. I'm gonna put this right at F1, cool. And I'm gonna click on OK. Automatically, everything should be in here. All right, so what I'm gonna do is I wanna just make sure, let's see if our LSD is working on this one right here. Our Fisher's LSD, 1.17. Let me check my work. All right, that one worked. So something is going on that first one. Make sure you get it right. What is my F-stat value? All right, 4.2 decimal places, 4.94. Do you see that? 9.4. Check your work. Outstanding. All right, so you should be able to do this and get this rocking and rolling. All right, so that is my class for today. Make sure that your Excel templates work. What we're doing is we can either manually calculate ANOVA, or we can use a data analysis toolkit to get the ANOVA quickly and easily. All right, the Fisher's LSD, make sure that that calculation is working correctly. Reach out to your professors, figure out what is wrong with that Fisher's LSD. That is an example that will be on your exam. Let's go. Let's get that A. Have a great